In this quick video, what I'm going to do is walk you through an example of how to graph a piecewise function. Now, piecewise functions are unique in that they all kind of look like this. We have the name of the function equal to a squiggly bracket with a bunch of stuff. And so what I want to do first is just kind of explain what this stuff means. Now, piecewise functions are sort of like a recipe. And what this recipe says is that our function f of x is equal to two different functions under certain conditions. So this particular function f is equal to the absolute value of x only for x values that are less than or equal to -2. For any x value greater than -2, the function happens to be equal to negative x squared. So in order to effectively graph a piecewise function, you have to know quite a bit about the functions that make up the piecewise function. So let's for a second just think about the absolute value of x. The graph of the absolute value of x is pretty simple, and you've probably seen it before. It starts at 0, 0. If I move over 1, I go up 1, over 2, up 2. Kind of looks like a line as we move to the right. But as I move to the left, once I start taking the absolute value of negative numbers, remember those values become positive, resulting in a left branch that looks like this. So for the right side of the absolute value function, I sub in 1, I get 1. I sub in 2, I get 2. But the left side takes those negative x values and just makes them positive to get the y values. Now the graph of y equals negative x squared is just a base parabola that's been reflected over the x-axis. So I know that I should be starting at 0, 0. If I move over 1, I'm going down 1. Over 2, I'm going to go down 4. And you can get these y values just by squaring the x values and then making them negative. So these are the two functions that make up my piecewise function. And an understanding of the graph of each of these is key for determining what this piecewise function is going to look like. So let's take a look at f of x. I'm going to draw a more accurate sketch here because my recipe here tells me that I need to look at -2 in particular, because that's the point where my piecewise function changes from one function to another. So looking at the first ingredient, if you will, for the recipe that makes up my piecewise function, I know that for every x value less than -2, my piecewise function really just looks like the graph of the absolute value function. So looking at -2 on the absolute value function, I'm really only interested in this little branch here up until and including -2. So when I go to draw my piecewise function, I'm going to just draw a little branch that starts at -2 and goes kind of up toward the left, just like the absolute value function does for every x value less than -2. Now this is just a rough sketch, but you can see here that the y value at this point is 2. If I move to the left to -3, the y value should be 3, and so on and so on and so on. Now looking at the second ingredient in my recipe here, I know that for every x value greater than -2, so if I move to the right, the graph of my piecewise function is going to resemble the graph of negative x squared. And when x is equal to -2 on the reflected parabola, I have a y value of -4. So going back to the graph of my piecewise function, at -2, I'm going to go down to -4, which is approximately right here. Now you'll notice I'm not going to fill in the point at -4. And the reason for that is because my recipe tells me that the piecewise function is only equal to the absolute value of x when I'm at -2, not the reflected parabola. But for every x value moving to the right from -2 over, I'm going to draw what the graph of the reflected parabola should look like. So I know I have a point at -2, -4. I should have another point at -1, -1. I should have another point at 0, 0, 1, -1, and so on and so on. And if I connect those points with a nice smooth curve, I get what should be the final graph of this piecewise function. And if I review my instructions or my recipe, this tells me that the graph of f at x, when it's less than or equal to -2, should look like the graph of the absolute value of x. And you can see that's where this little branch here comes from. And remember that this dot here is filled in because of the less than or equal to -2. Remember that for any x value greater than -2, as I move to the right, the graph of my piecewise function resembles the graph of negative x squared. And you'll remember that I don't fill in this point here because my ingredients tell me that at -2, I'm actually equal to the absolute value function. So that's just a quick walkthrough of how you can use your understanding of two basic functions to produce the graph, or a sketch in this case, of a piecewise function. And this process will work for any piecewise function. As long as you have an understanding of the two simpler functions which make up the piecewise function, you should be able to produce its graph. Hope this video helps, and as usual, thanks for watching.